Hello guys, welcome back. We are working on the back side of our handout for the lesson for IVT. These last couple of examples are going to kind of solidify, hopefully for you guys, the concept of what the intermediate value theorem basically is about. And so let's get started with example 3. It says a truck travels along a straight track during the time interval from 0 to 30 seconds. So that's the interval that we're looking at. So that's our A, B thing here. And don't worry, we don't have to write the whole song and dance for this. Just the idea of the concept of what IVT is. And notice that our values in our chart are from 0 to 30, so it's good that we have given this. The truck's velocity in meters per second is a continuous function. So highly important word right here. We have to tell you guys it's a continuous function, right? It's got to be stated there. The table below shows selected values for this function. So we're looking at these problems and we're given the velocity of our truck. It says for 0 to 30, so in this interval, what's the minimum number of times? The minimum number of times, not how many, but what's the least amount of number of times that the truck must have stopped. Justify your answer. So when I teach this to my students, I go a little bit further. So something you guys are going to learn later in this course is something called particle motion. And so what I want you guys to just know really quickly to kind of really solidify this, and you may have actually learned this in physics, is that when velocity is positive, then our particle, or in this case our truck, it's moving forward. It also can be moving up, but our truck is not going to move up, so it's moving forward. So when velocity is positive, let's just say that our truck is actually going to go forward. And then when velocity is negative, then our truck is moving backwards. Okay, so we're in reverse. So at time equals 0, this is negative 10 meters per second. This means we're going backwards. So the truck's going in reverse. And then at time equals 5, we're still going in reverse. Now, somewhere between 0 and 5, we could have went forward, but right now this is the only information that we have. So we know that we're definitely going backwards from 0 to 5. Again, we don't know anything about forward, so we're going to kind of just assume that right now we're still going backwards. From 5 to 8, we're still going backwards. So all of these are backwards, backwards, backwards. Now, from 8 to 12, we went from our rate of negative 5 meters per second to a rate of positive 2 meters per second. So what this means, guys, is that on the interval from 8 to 12, we were working backwards, we're going backwards, and then sometime we had to stop, right, to move forward. So if you guys are like walking backwards and you start walking forward, even for a millisecond, you had to stop. You had to stop. So here's the first time, this is the first time that the truck had to stop. That means that the velocity had to be 0 at some time between 0 or 8 and 12. And you guys will learn, again, in particle motion, when velocity is 0, our particle is at rest, okay? So between negative, and that's, again, IVT says that 0 is in between negative 5 and 2. So from 12 to 20, again, we're going positive, 2 to 8. We could have went reverse in that interval. We could have, but we don't know that information. But we do know that we'd stopped here. Well then, again, from 20 to 24, we're positive, we're going forward, and now we start to go reverse again. So then we know there's our second time. So somewhere between the interval from 20 and 24 seconds, velocity was 0 again. And then a third time, ladies and gentlemen, again, we're reverse and we're going forward. So really this question just breaks down to when did my signs change from positive to negative and negative to positive. But I want you guys to get the idea of what's actually happened in this question, right? So that's the idea. So what's the minimum number of times that the truck must have stopped? The answer is 3 times. Again, it could have happened a lot more, but we know at least of 3 times, and we can justify our answer by saying it's IVT. By IVT, we could also say that velocity is 0, or velocity changes signs. Changes signs. This is how I would justify it using particle motion. Changes signs on those intervals, on the intervals that you see, and then I would list them all out, but I don't need to do that right now. All right, so there's our idea for example number 3. So again, I'm hoping that the more examples we do, the more this is going to make sense to you. So we had a point at 8, negative 5, and then we had a point at 12, 2. Well, if you connect those 2 points, guys, you had to go through the line y equals 0. All right, so hopefully, again, IVT, because IVT is one of those things where you get it, and once you get it, it's so common sense, but it takes a while for some people to process it. So if you're still not there, it's okay. I'm going to try to win you over by the end of this video. All right, guys, let's go ahead and look at example number 4 now. For question number 4, it is a calculator problem. So it's important that we have our calculator out. So I'm going to have our little calculator out here in a second. It says let f be the function defined below. It tells us that the intermediate value theorem applies. that's awesome. If it tells you that IVT applies, the first thing that you can say is that this function, you know it already, has to be continuous on the interval that it's given to you. All right, so it says it applies on the closed interval from 10 to 12. Is this continuous everywhere? We don't know, but we at least know it's continuous on the interval from 10 to 12. It says, can we guarantee a solution to which of the following equations? So basically what we have to do is here, we have our function, and we're wondering, okay, which of these 4 equations will be a solution to our equation? So the first clue to do this problem is, well, it's a calculator problem, so we're going to graph it. Right? So I'm going to go ahead and have my little calculator up here. And again, to save some time, I went ahead and typed the function out for you here in the calculator. And so we're going to graph it. Oh, and the other thing I want to tell you guys as this is going on is that I changed my window. I changed my window from 10 to 12 because that's what I want to see. Right? So if you look at my window, I changed it from 10 to 12. I did half a scale just because I want to see a little bit more. And then my max and my min for my y values, I looked at my answer choices. So over here in A, it tells me 0, and then up here at 67. So I wanted to choose my y values that was somewhere in that range. So I just chose one that was a little bit less than 0 and one that was a little bit greater than 0. Okay, so again, let's look at our calculator. So I did that. So that's why the numbers were -1 to 71. So yeah, so there's our function. Great, we saw it. It looks like that. Fantastic. So that doesn't help us with our solution. So then what we're going to do here is we're going to type in our answers. We're going to type in our answers that you guys see, and we're going to plot them. And so remember, I'm doing them in the order that it's given to me here. And some of you guys who have fancy calculators, you can change the colors, and I think that would be really awesome to do. I could go and change the line depth, but I don't really care about that. So let's go ahead and graph all of our functions. One of them is going to hit this line. One of them's going to hit this line. So we got to figure out which one it is. So when we graph it, the first one is 0. There's 27. There's 41. And then there's 67. And so notice that the only one that hit this line was actually the 41.41. So we could just very carefully go back and say, okay, let's just verify that that's the right answer. So we can go ahead and clear everything else that we have here. And then it's okay, let's just graph it, make sure that's the right one. I forget that slowly we're going to have this line come back again. But trust me in saying that when we do graph this thing, that our answer y equals 41.41 is yes, it is a solution. So guys, if we were to take this point right here and bring it down, this would be the C value. Again, we don't know what the exact C value is, but that's what it is. So this answer is going to be equal to C. All right, so there is example number 4. So let's see what we can do for the next couple of examples. All right, guys, let's start example number 5. Number 5 says the functions f and g are continuous. So again, there's that word, continuous. It says the continuous function h is given by our function f of g of x minus x. The table below gives values of the functions. Explain why there must be a value t. So let's actually listen to this wording. Explain why there must be a value t for the interval from 1 to 4 such that h of t is equal to -1. Where have we heard that before? Back in example number 1 from video 1, look at what I wrote in orange. There exists a c on the closed interval 1 to 2 such that f of c is equal to 0. I did the same thing with example number 2, and I didn't realize how messy this was. But anyways, there exists some value c on the closed interval such that g of c is equal to 5. So if you learn how to justify your theorems, then you should be able to know what theorem to use later on when we introduce you guys to multiple theorems. Okay, so now we know that this is going to be IVT, right? And I just want to say, and I always get ahead of myself a little bit here, that notice this is h of t equals -1. If there had been a prime here, then it would be a completely different problem. I'm not going to get into that right now, but I want you guys to just be really, really careful how you read the questions and make sure that you interpret them the way they should be interpreted. All right, so let's look at this problem. So we're going to have to find h of 1, right? We're going to have to find h of 1 and h of 4. And so I'm going to tell you guys right now, and you already know this, I hope, that when you find the values for h of 1 and h of 4, one value is going to be above -1 and one value is going to be below -1. If that's the case, then you know IVT is actually going to work here, and it's going to be. It's telling you it's going to work, right? So let's look at it. So h of 1. So we're going to go ahead and plug in here. We're going to get f of g of 1. And then we're going to go ahead, and there's an x right here, so we're going to plug in 1 for that x. And so we're going to get f of, so g of 1 is 3, still minus 1. And then f of 3 is negative 3, minus 1 is equal to negative 4. So I know that the point 1, negative 4 is a solution to my function h of x, right? And so my y value is negative 4, which is below negative 1. So I know when I plug in 4, I better get a value that's greater than negative 1. So let's check it out and see what happens. So we're going to do f of g of 4. Be careful here, minus 4, right? So students just kind of get a little sloppy with this and they think, oh, it's just minus 1 because they look up here. No, it's minus x, so it's minus 4. So just be careful with that. So we're going to get f of g of 4, where g of 4 is 2, right? And then f of 2 is 8. And so, look what I just did. What, 4? Minus 4, so we're going to get 4. Right, we're going to get 4. So this is going to be 4, 4. So we have a value that's above, and a value that's below. All right, a value that's above and below. So we now know, and I'm not going to write it out for you guys in words, but I'm going to say it to you pretty slowly. So when we want to justify our answer, this is what we would say. Right, we would say since h of 1 is equal to negative 4, which is less than negative 1, which is less than h of 4 equaling 4, and h of x is continuous, by IVT, there exists a t on the interval 1 to 4 such that h of t equals negative 1, right? And that's how you would justify that problem. And it's exactly the way that I justified example 1 and example 2, all right? So that's it for that problem. So again, I'm hoping that you guys are really understanding that whatever this value is here, whenever you find f of a and you find f of b, one is above it, one is below it. And you can only do it if the function is continuous on the given interval. All right, let's go down to example number 6. So 6 and 7 are just conceptual problems just to see if you kind of understand what IVT says. So for example 6, it says the table below gives values of the function g at select values of x, okay? Which of the following statements, if true, would be individually sufficient to conclude that there exists a c on the interval from negative 2 to 2 such that g of c is equal to 6, okay? So basically, again, look at the words, right? There exists some value c on the interval such that g of c equals 6. That's telling me what do I need for IVT to occur. So 1 says g is defined for all values of x on the interval from negative 2 to 2. So we have, and I wish we had more little room here, but so from negative 2 to 2, it's saying that they have to be defined. Well, what about if I give you something like this? Look at that. So it's true. Everything on this interval from negative 2 to 2 is defined. But if you guys look right here, we have a hole. We have a hole. So it's still defined, right? It's found at this value right here. So there's a hole here. So removable discontinuity, right? Removable discontinuity actually says that this is not guaranteeing that IVT occurs because I have now used my counterexample by removable discontinuity. All right. So yeah, I'm continuous here. Here, my limit exists, but it's not defined at this value right here. So g is defined for all points. Yeah, that's great and all, but it's not going to prove IVT. G is increasing on the interval from negative 2 to 2. Well, again, ladies and gentlemen, this is not true because in order for IVT to apply, you don't need something that's strictly increasing or strictly decreasing. So I've showed you guys in examples before where I said, okay, we've got a point here, we've got a point here, and I said I can go and do this, right? And IVT is still going to apply. It's still going to apply to the values that are right here. So it doesn't have to always be increasing or decreasing for IVT to work. So this doesn't guarantee that IVT works. The only one that does is going to be 3, because again, if g is continuous on the interval, negative 2 to 2, then you already know, based on the theorem we said before, this theorem right here, right? If it's continuous on an interval, and we already know that f of a doesn't equal f of b from the chart, there we go. We can say it. So f of negative 2 is negative 4. F of 2 is 20. They're not equal to each other. So if g is continuous on the interval, and f of a does not equal f of b, which in this case is not, then I can say this by the theorem. So this is that example where you really do have to know the theorem pretty well. And if you know how to write it out, then this should make more sense to you. All right. I hope you got it in you. We got one more example to do, and we're done with this lesson, ladies and gentlemen. It's example number 7. And again, let's go and see what we can do with it. Okay, so I'm going to head and give us some room here so we can kind of really talk about this question for a little bit of time. It says, let the function f be a continuous. So again, there's that word, continuous on the closed interval from negative 5 to 9. So I'm going to go ahead and I'm going to just go and do negative 5 here and 9 here. I don't need to do all the tick marks for it, so we're good. It tells me that if f of negative 5 is negative 1, so it's telling me already, it's already telling me my point, negative 5, negative 1. And it's also saying to me if f of 9 is 7, okay, f of 9 is 7, which of the following, if any, which of the following statements, if any, is guaranteed by the intermediate value theorem? All right, so let's look at them. So all I know right now, if this is the IVT theorem, I know that I cannot get out of this range. I can't come over here and then come back around, right? Because that's going to make the vertical line test fail. So I know I'm in the intervals from negative 5 to 9. But remember, I can go up and down as long as I'm inside the house. So let's look at the first one and see, does this have to be true? Does f of 0 equal 0? So if I want to connect these two dots, must I go through the origin? Well, let's show it. There it is. There's IVT. I did not cross the origin, so this one is not guaranteed, right? It's not guaranteed. All right, so let's look at question B, or part B. It says f of c equals 1 for at least one c between negative 5 and 9. So this is saying that I have to cross the line f of c equals 1, right? This is the line y equals 1. I have to cross that on the interval from negative 5 to 9. And so if I'm connecting these points, well, that is absolutely true. I don't know where I can cross it. I can do that. I could go and do this, right? So all these are my values of c. I just don't know what they actually are. I can go and do that. I can cross it at multiple points. So I know that this has to be true. This has to be true. Now we're going to go ahead and talk about the other two to make sure you guys really understand it, but this is true. So the key thing that I want to say about this is that it's between negative 5 and 9, and we'll talk more about that here in a second. All right, so let's look at the next part. Okay, so part C says that my y value has to be in between 7 and negative 1 for all values of negative 5 and 9. I like this example because this is, again, using my house analogy, this is saying that I have to stay in between 1 and negative 1 and 7. Well, I don't have to. Remember, we can go in the basement, because remember, these are the y values. I can go in the basement, and can I go up to the attic? So I know that this is not true. This is not true. My y values are not restricted like my x values are. All right, I have to be between negative 5 and 9. Again, the walls contain us, but we can go in the basement and we can go upstairs in the attic. So that one is not true. And so the last question here is f of c equals 0, right, which again is the x-axis. But be careful with this because it says between negative 1 and 7. Well, negative 1 is here and 7 is here. So this is saying that I have to cross the x-axis on this domain, right? This actual range. So, well, domain. So what I'm saying here is, well, let's go and do it like this. And this is IVT. I don't have to have a 0 in between the intervals from negative 1 and 7. So this one is also not true. And so this kind of goes back up here to B. Goes to B is if I had changed this example and made this negative 5 and 9, this one would be true. All right, this wouldn't be true. So we always want an answer that's restricted to negative 5 and 9. So there you go, guys. There is IVT. Hopefully you understand that a little bit better. If you have any questions, please feel free to send an email to your teacher and see if they can explain it a little bit better than maybe what I did in these videos. But hopefully it made sense to you guys. I appreciate you watching them, and I'll see you guys in class.